Thanks everybody for joining us. We've all been introduced, so yep, that's all of us, and a little bit more information. So Andrew Dunar is a VR developer, and he does a lot of our content for our gloves, which I will also introduce. And then Stachiw is actually a customer of one of ours and has been working with us on a project, which we'll also talk about, developing with our gloves as well. So we'll get to hear how Andrew's work goes and a little bit how to, when, and then Scott will weigh in a little bit from an external perspective. So first, I can't give this talk without saying why we're here. We're here for the first time with the HaptX Gloves G1, which give the most realistic touch experience. We have 4 in our booth, so if you want to try them out, you can try them out and feel for yourself what they're going to be talking about. We're going to be focusing on the SDK, which enables the different types of haptic feedback here, and they'll talk about how and why and when. So our SDK has a Unity and Unreal plugin and also a C++ API, so you can do easily VR projects. You can also do robotics or any custom applications, and we're also introducing a ROS node to make robotics even simpler. So before I go a little forward, so the gloves have a few types of feedback. There are tons that are out there. There's heat, there's pain, all types of haptic feedback, touch feedback. We focus on tactile because your hands are what you use in your job. So you need to be able to feel, for example, my watch, I can feel the size of it and stop it. I can feel the buttons and I can use it without even looking at it. So those are really important for training both people and robots for the future of the workforce. So that's a little introduction to those types of feedback. Andrew's going to talk more about how those interplay in the SDK.
Yeah, thank you, Kaitlyn. The first type of feedback is our force feedback, and that is the resistive force you get when you close your hand around an object to make that object feel solid. And what we're doing is we're working with the colliders on that object in the game engine. And here in this shot, you can see we have our visualizer showing what our force feedback is actuating and what isn't. So if we go on. Then we have our tactile feedback. That's the actual sense of touch we get in our fingers. And this is working on the visual geometry here. So what's happening is our tactors aren't just on or off. They have pressure. So as you press down very lightly, you can see in our visualizer that the tactors start to light up very lightly and then they become very bright. And that's because you get that sensation of a light touch to a heavier touch as you go on. And then as we go on, this is a new feature in our SDK where we can actually actuate our tactors faster than the game engine loop, and we call it our vibro-tactile feedback. And we can actuate that either through game logic or through texture-based information. So I've actually applied a texture that's rough to this flashlight. Now I've added it to the material so that we can see it, but there's information encoded in that texture to give it a rough sensation versus a smooth sensation over the flashlight, and then using game logic to fire an effect when we press the button on that flashlight. So how does haptic feedback work? Why would we want it? Really, Scott here is a great example of just taking that feedback and running with it with his content. Would you like to elaborate on what you do?
Yeah, for sure. So the BNSF project was the first project we had a chance to utilize these gloves with. We have used a lot of different types of haptic devices on the market. Those different types of feedback that Andrew just talked about are super important in the 430 unique technical interactions that are part of this BNSF project. There are 4 modules that cover the technical training for repair and maintenance within a Tier 4 diesel engine. And so for us to make sure that this is effective in VR, we have to make sure it's not just point and click. It has to be interactable. When they're grabbing a torque wrench and they have to know how many foot-pounds they're going to be torquing down a bolt, they need to practice that. They need to put on the torque wrench. They need to move the torque wrench. They have to feel some type of vibration in the controller to understand when that foot-pounds is reaching where it needs to be. These are a few of some of the things that we have in there currently before haptics was introduced. And while it was effective, it was not the most effective way of introducing the training modules and making sure that the comprehension of the modules was being absorbed by the learner. In contrast, now that we've incorporated haptics, we've been able to now grab onto that torque wrench, for example. When we attach it to the bolt, we're not just giving a general haptic vibration from a controller. We can actually give pressure to the insides of the fingertips where they're specifically touching and pulling against the torque wrench, which blows my mind because it's a lot more accurate than just having a vibration in the controller.
In fact, one of the things we can actually even do with a wrench like that is we can add haptic effects to it so that you can actually feel that ratcheting back. Because as you ratchet back, it clicks, and you can feel that in their demo.
Very exact. And as developers, we are all magicians, right? I mean, we are trying to sell an illusion that tricks the mind into believing that we are where we are and we're doing what we're doing. Believe it or not, this picture here, the engine itself is huge. It's a locomotive engine. And when we put colliders on all of the faces and angles of this engine and allow an individual to reach out and touch the contours of that engine, it puts a smile on their face. They realize, okay, I'm here. It helps with spatial awareness, because I don't know how many of you that have developed content and put something in front of a user and said, okay, pick that up. And they just kind of reach out. And they go, I can't grab it. It's broken. Well, it's because they don't realize, oh, it's three-dimensional space. I can reach out and touch that. Once you've introduced true haptics within a space that allows for touch of all of the objects in the space, it helps connect that in their mind and realize, okay, I can actually move in this space. But it's more than just the haptics itself. Like Andrew mentioned, those tactile feedback in the fingertips, it's a lot more realistic with these gloves compared to most that I've used, just because I can feel very specific textures when I'm touching those areas within the scene.
Yeah, I know. I had the opportunity to come to your offices and work with you and try out your demos, and it was a great experience. And then see other people going through your content and them just reaching out and touching the locomotive and going, oh, wow,
Yeah, it was cool.
That is awesome. But then one of the things I saw was like this interaction with this feeler gauge here. As you reach down and touch that, you're trying to adjust the backlash on these gears and using a feeler gauge, using two hands to try and get that the right spot. Like, I don't know how you can convey that kind of interaction well with controllers. That's really an haptics type object.
It's hard, right? But that's an obstacle that we all face, and we work through it by dealing with the obstacles we have with just regular controllers. Yeah, for that in particular instance, and that video that's in there, you're actually feeling that feeler gauge with your index finger and thumb, and you're pulling it left and right, and there's gear lash within the gears of the fuel pump. So as you're pushing the fuel pump forward, we're actually able to control in the SDK how much tactile feedback is placed on the fingertips. So as they're pulling it out, you can actually feel it sliding easily or pulling tough against the gears as you're providing that lash. So again, it's more than just a step. It's not a procedure that we're trying to make sure people understand the steps. It's the feel of the step. It's the feel of what you're doing in that moment that makes it stick.
Yeah, you already mentioned your wrench interaction, and that's actually a really common interaction. I've actually worked with a couple customers with that same type of interaction, wanting to know how they could do that, wanting to be able to use tools. This is from a demo I was developing, where you can actually pick up these tools and use them like you would in real life, put a bolt on and ratchet it in real time. And feel that, feel it click, feel it start getting tight. It's a very powerful sensation to be able to just kind of it's a wow thing that I can use tools here.
Mm-hmm. Same thing goes with actually your switches, your gauges, anything that you can feel both the feeling of the switch, but also the snap, the click of the switch is important.
Yeah, when you're working with switches, they don't just go down and up. You can hear them, they click, and you can feel that click in your fingertip. And that's one of the things we can simulate. Through a haptic effect, we can fire a haptic effect that kind of simulates that click. You pair that with an audio cue, and that's a really powerful thing. So, you can have switches all over, a number of different types of switches. Imagine like a cockpit of a helicopter or something, where people are going to reach out and they want to be able to switch a switch and flip it and be able to feel it and not look at it. And having that feedback where you can actually feel it engage and click without even really looking at it is a powerful thing.
There's actually two other things, areas that were important to us as well with BNSF. The tubes of lubricant that go on all the seals. If you're grabbing with the grip trigger on your controller and then you pull the index trigger to let the lubricant come out of the bottle onto the seal, again, you can practice those steps. But it's important to know how much lubricant you're placing on there. And what I really was impressed by was how much control we had with grabbing something that was cylindrical, applying amount of pressure with my hands that actually increased the particle illusion effect of the lubricant that's coming out. So people can actually practice how much you're placing onto the seal. And then the feel, that vibro-tactile feel of the fingertips, how many sensors are in that thing?
The fingertip itself, I don't know offhand.
Each of the fingers are a little bit different. We've optimized it for how much you use that finger, what the different areas are, how sensitive they are. So each of the fingers are a little bit different, but each hand has 135 all over tactile.
Which is crazy. And what that means, so for me as a developer, what that means is that I can be very specific in how the feeling of the texture is. For example, the fuel injectors on these machines are huge. They're this big in diameter, they're about this tall. And when you're standing next to the engine's here, and you pull this thing out, and there's a point where you're supposed to check the quality of the cylinder you just took that out of. And currently, before HaptX gloves, you would have to take your controller with your virtual hand, and you put it in there, and you're like, okay, I checked the cylinder. You checked off the box, but you didn't actually check it. But now, I can take your finger, place it against the inside of the cylinder and feel the cylinder wall, and then rub against the cylinder wall to feel between anything that might be smooth or rough. And now I can actually check for damage inside the cylinder. It's a game changer and actually made that a truly effective part of the module that blew not only my mind away, but obviously with BNSF and their trainees as well.
Yeah. Then there's also like virtual menus too. I know going through your content, there's menus you walk your way through. Just having this menu in space that you can interact with in VR, and then not just touch it and think, oh, did I touch it? Be able to feel it, and then we can give that click. Like when you press a button on your phone, you feel it. The phone vibrates and it feels like you've pressed a button. We can do that in VR. That's something you can't really do. You can point at things in VR, but now with the gloves, you can reach out and you can touch it. You can press that button. You can have a screen, like a display screen like you would, that's just a touch screen. Now it's a touch screen in VR, and you can work it the same way. I mean, Unity's got great, their canvas and stuff, and we can just tie right into that, use the triggers from that to fire events.
Implementing is easy. Also HMI screens, so we have a lot of HMI screens we're introducing, and people are touching, and they're always having trouble, because we do finger touch, right? You have the finger, the physical finger, and you can touch it within the HMI screen. But the feeling of the touch on the screen is more accurate to what they're touching, and feeling the press of the screen was definitely an addition to it.
So developing with haptics, how have you found that? How has it been working with the plugins?
So we've all worked with SDKs, and there's always something you might feel is difficult to work with an SDK. I will be honest, the installation of the tool set that haptics provides does open up its own Unity project, which has everything that's installed in there. It has a separate application that works with the hands to change the way your hands look. The only difficult part of it is that you do have to go through their Unity project. If you have a project you've already started, like we did with BNSF, you will have to go through their Unity project and pull out the parts that you want, export them as a package, and put them into Unity. It's not a big deal. It takes about an hour to do. If you haven't started a project yet, the package that they have that uninstalls for you is right there. Everything you need is right at your fingertips. So it's not hard to do to get it implemented, but there is that one step of getting it popped into your project. Once it's in there, though, the components, you have rigid bodies, you've got your colliders, but they have a whole list of components that just right-click, add it right to your game objects to make them specific to the type of tactile touch you're looking for.
Yeah, and we can actually add to an existing game project, too. We can go in and install our plugins in existing projects, and then there's some settings in the projects itself that we want to set up so those components work best for us and for haptics. But for me, it's always been the difficulty is thinking about things differently. We used to be thinking about the steps. How do I show this step? What step comes first? What step comes next? now we have to kind of think about how do we actually do these steps and how should they feel? And it's a different mindset. I have here from our Unity plugin, a real simple button. This comes with our SDK, with our plugin, and it's something that you could use as it is or use as an example. And this is just kind of showing how easy it is to set up just a haptic effect, take a button. Kind of the big things on here are it's 2 components. We have a 1D translator, which is a script that comes with the plugin, and that extends from the configurable joint and adds a whole bunch of functionality and ease of use. And then the other thing we have on here is our haptic effect. And then to get that to work, this is all the code you need. 2 functions, the start function where we assign a couple variables, and then we've set up a non-state change function where we actually start the effect and stop it. So that's all the code you need to get that to play. So it's pretty simple. Same thing with Unreal. It's the same setup. There are components. There's a translator component. This is inheriting from a physics constraint. In physics, it's the same thing. Unity and Unreal call them different things, but under the hood in physics, it's the same exact thing. And then we have our effect also. And then that's all the blueprint code needed to set that up and have that play that effect.
I will say also it was very easy for us because we have a lot of prefabs, of course, that we're using for bolts and nuts. So as long as we just took those function calls, applied them within our scripts on our prefabs, it obviously automatically applied to everything within the scene. So it's not like we had to start from scratch on anything because we did start with a project that was already built. So implementing it was easy on that front. I also like that you guys do have the capability of the haptic effects being organized on the components. So like your tactile touch for the textures.
Yeah.
Can you walk through a little bit of how that gets applied to that?
So with a texture object, we actually have a component that gets applied to that object that then you assign the texture to. And then it has some values in it that basically says what's the frequency range that the values in the red channel of that texture represents, so that if it's white, we're vibrating as you run your hand across it at this frequency. And if it's black, as it moves towards black, what's the frequency we're vibrating as you run your hand over here. But then we also have height information, so we can add height offsets. So think of like a normal map, what that does, how much that adds visually to an object. That's kind of what the height offsets do for adding texture. So you can have black it would actually be in our blue channel, subtracting some height from that, and then white values adding some height. So as you run your hand across, you can feel all these lumps and bumps that don't really exist in the visual geometry, but they feel great and they look great.
And the last thing I would add as a developer as you're looking at integrating haptics into any project you're doing is, like Andrew had mentioned, think about these like you do with physics hands. If anyone's used Hurricane VR or any other physics hands applications, just knowing that your items and tools are now completely manipulated by every single joint and fingertip, and keeping things that are properly separated on a table of tools, for example, adjusting your turning off and on your colliders when needed and necessary. But think outside the box when it comes to what you can now do mentally, like I talked about with that cylinder, and interacting with that space with those hands. It's another sense that brings in that reality. I love that also the fact that you can now use that instead of your sight. There's many times where there are objects behind part of the engine where they're supposed to reach around, find them, and tighten them. And of course, we always turn the opacity down on the object and put indicators, and sure, it shows them where it is, but does it really allow them to make the cognitive decision of where the object is and how do I adjust it and manipulate it? But now we have the touch, so we can do that. So again, rely on those things now that you have that tool set available to you.
Yeah, and if anyone's interested in actually how some of these kinds of interactions are set up, I'm going to do a couple workshops here. At our booth at 3:30, I'm going to do one for Unreal, and then tomorrow morning at 10:45, I'm going to do one for Unity, how to set up some more complex interactions. And I'd be happy to answer questions during that time. I'll answer questions now and right after this session. So.
And Andrew, a few other members of the HaptX software team are going to be in our booth for the rest of the show. So this was a very small amount of what both of these people know. They have a wealth of information, knowledge, experience. So if anyone has any questions, a few software team members will be in the booth. Scott is also going to be hanging around until I think he said about 3 at the booth. So if anyone has any experience or any questions about his experience, wants the honest answers, but the real answers, Andrew will also be honest with you. Stop by our booth. It's booth 417. I'll also be honest. But booth 417, come by, ask us lots of questions. Also, we have 4 systems up and running. Some of those screenshots were from our demos. If you want to touch the Urchin, the control panel, do a crane, other examples of what our customers are doing, come check out our booth. Try it out.
Any questions? Sorry. No? Cool. That's all we got. Thanks, guys.
Yeah, thank you.
Thank you.